Greetings, Miss Esther and fellow friends.
Hello.
My name is Elbert Liem. I'm from 9E, and today I'm going to give you a presentation about my dream job. Alright, so my dream job is a chemist. When I was a kid, I thought about being an astronaut because I like space and stuff. But then I have to wear glasses, which is prohibited by every astronaut in the world. So I kept thinking, I kept revising, and then I found out that I am really good at science, especially chemistry. So I decided to become a chemist when I grown up in the future. And what kind of chemist do I want to become? At first, I was thinking about become pharmacy chemist that makes drugs and medicines. But I realized something that is bigger than just pharmacy, something that maybe could change the world. So I decided to study nuclear chemistry and mineral chemistry. Why do I want to become a chemist? I want to become a chemist because of two things. First of all, because chemistry is always and forever be my passion and my favorite things to learn. And secondly, I saw a real problem that our community is facing presently. Yes, it is overpopulation. Right now, there are approximately 7.7 billion people on Earth. And I must say, that's a lot of number. That's a lot of humans, 7.7 billions. So I want to study about nuclear and become a chemist that develop a nuclear weapon in order to help solving this problem.
Excuse me. By that you mean to reduce the population of humans?
Yes, by half of them. So this world and even maybe the universe can be brought back to balance, as our thing show. And chemist jobs. Chemists typically specialize in biochemistry, neurochemistry, nuclear chemistry, and sometimes theoretical chemistry. In the pharmaceutical industry, chemists develop drugs and study their properties in order to determine the quality and stability of the medicines. And sometimes even chemists work as forensic science to establish evidence in criminal investigation. And sometimes also experienced chemists also involved in preparing for product licenses. And this is about my future university. About my future university, I want to study in ITB. It's Institute Technology Bandung, in Bandung, of course. If I'm going to stay in Indonesia. If I were lucky and smart enough, or a little bit rich, I would like to study in Monash University in Melbourne and study about nuclear chemistry there. Or if I were even smarter and my parents were richer, I would like to study in America, especially in MIT, Massachusetts. And this is about company and places I'm aiming to work at. In the future, I'd like to work for NASA because I want to help them in order to reach the outer planets like Mars and Venus. And if not NASA, I would like also to work on Rosatom in nuclear energy division. Rosatom is the leading nuclear company in the world. It is from Russia. They develop a lot of nuclear power plant and nuclear weaponry. And they also involved in the nuclear warfare also. And to fulfill my childhood dream of a balanced world, I would like also to work on NORAD. NORAD is the acronym of North America North America Aerospace Defense and Command. They control all ballistic nuclear and that kind of missiles and nuclear weapons in the United States of America. I'd like to work there and develop a new type of nuclear weapon that maybe can help people out. Right, so now I'm going to explain you some of the laboratory equipment. Maybe some of you already recognize a few of these things. So I'm going to explain to you the general equipment. So first of all, this one is like the spoon one. This is a spatula. You can use this if you want to add a powder to a mixture or to stir the mixture up. And this is a mortar and pestle. Alright, so this thing is sometimes if the mineral you want to use is already hard and not in a powdered form, you can use it to break the mineral out into dust. And I'd like to introduce you to Bunsen burner. This is the same as stove, but it is for chemistry only. It's specialized for chemistry. And right here, the upper here, I think you all already recognize this. It is the test tub. So when you want to mix between A liquid and B liquid, you mix it right here in the test tub. So this is the fluoride flask and element flask. What's the difference between them? And so usually the fluoride flask is used for gas substances like chlorine and nitrogen, and the element flask is usually used for liquid substances and dangerous chemical like iodine and hydrogen. And the upper one, it's the beaker. It is for storing the liquid and the result of the experiments. And this one, the test tub holder, this is really important because sometimes if the test tub gets too hot because of the boiling degree, you need a test tub holder to hold the test tub up so your hand doesn't get burned. So this is the laboratory safety and chemical hazard side. And up right there, the X cross in the square, it means harmful. So if you touch that or like spread it to your skin, it can harm yourself.
Wow.
And this one is explosive. This one, the like meteorite one, is explosive. So the chemical substances that has the sign is usually very explosive when it get ignited or it get set to the flame. And this is corrosive. It's usually corrosive. It's usually on acid. So when you put the corrosive substances to usually metal or wood, the wood will get dissolved, or even the metal also will get dissolved. And this is dangerous for the environment. So it's not good if you put it on the air or on the ground. It is not good. And this is flammable and oxidizing. It's actually different because when it comes to flammable, I mean if you set it on fire, that's it. It will get burst on fire. What oxidizing is if you rub it on something like for the example things or pencil like that, the pencil will get burned.
Only by rubbing it?
Only by rubbing it,
Wow.
or usually put it soft. And this is toxic. I don't need to explain you about this. Alright, so the lower one, the yellow one is the first one. This is radioactive. It means some substances like uranium and beryllium usually emit radioactive to the space, and it can harm you. Radioactive is very dangerous. It can develop cancer in your body.
Yeah.
Usually leukemia and lung cancer. And this is biohazard. It means it contains virus or bacteria that can harm and make your body sick. Avoid this one and this one. Alright, so this is poison. So if you touch it, or if you inhale it, or if you even drink it, you'll die. So this is oxidizing. It's the same as the upper one. And general danger is the substances that usually all people already know that it's a dangerous substances. And this is explosive, flammable, and the last one is electrical hazard. It means if you put electric stuff on it, it will get electrified, and if you put your little tip or your finger here, you'll get electrified and you'll get burned. Yes. So I'd like to explain you the periodic table. So this man right here, his name is Dmitry Ivanovich Mendeleev. He's the creator of the periodic table. When he first created, there are only 108 substances in the periodic table. But now there are 118 substances and elements in the periodic table. So this is the periodic table. As you can see, right here is the halogen, or in Indonesia we call it gas mulia. And this one right here, the middle one, this is the navy one. It is transition metal. And this one, what is it? This is the post-transition metal. The difference is in the electron places. And this is in the upper lower one. This is lactonite and actinide. Right. Okay, this is the list of radioactive mineral that our world has. So the first one is uranium. Uranium is the fuel for usually a nuclear reactor and nuclear weapon and nuclear missiles. Sometimes the atomic number is 92. It is very radioactive. It is very radioactive, so it can harm your body. The second is thorium, which has the atomic number of 90. The third one is beryllium. This one, beryllium, it is one of the rarest radioactive mineral in the world. It is very hard to find, and it's also very expensive. And the fourth one is zirconium. Zirconium does offer a lot of usage in the nuclear warfare and in the nuclear reactor. And the last one is radon. Radon is actually not that radioactive, but is also categorized as a radioactive minerals. Next one. So this is my project that I've been working at for the last 2 days. So what I made here doesn't really have any relation with nuclear.
Is it
stuff.
dangerous?
It could be dangerous if you inhale it.
Everybody hold your breath. No.
No. So first of all, I want to ask: does anyone here has asthma? Or alright, I'm not going to set it on fire.
Nggak jadi.
Alright, so what I made right here, this is a smoke bomb. So this is a smoke bomb. I made it out of potassium nitrate and baking soda and also sucrose. I mix it up and I burn it with a crayon so it can emit a lot of color.
Wow, we would like to see it.
Outside.
Have we set it outside later on?
Alright.
Okay, after this though, I'm going to take a different picture. Okay, different video. But after today's presentation, and we ask the headmaster that can we do that or not? Okay.
Very good, of course.
Wait. Continue.
Alright, so this bomb I made it by my own. It contains potassium nitrate and baking soda and crayon and sucrose. So I made this by heating 4 of them with a great ratio of between sucrose and potassium nitrate. I mix it up, I heat it, and then I pull it on a mortar and pestle. So I destroy it into dust, and then I put it in this can, and I put this is the ignite for the smoke bomb. So if I set this on if I set this ignite on fire, it will emit a purple smoke because I use purple crayon.
Oh wow! We really want to see it. Is it will be like smoky all over this room?
Yes.
No, not here then, guys. We have to go outside. It will be dangerous for us because it's not just us but also others. So we're going to ask you to have this permission first.
And if you have asthma or asphyxia, you will die. It emits a lot of gas. And this smoke bomb is usually used by photographer for creating such a splendid effect, such a spectacular effect.
So you can really made it by yourself, actually, guys.
Okay.
Wow.
Yes, and this smoke bomb also used by the military for usually forest warfare and urban warfare.
Yeah.
Oh, and one more thing. This bomb is actually a very simple mixture. It's a very simple reaction. So I don't really found any difficulties in making this. Right. So that's my dream about being a chemist. I hope in the future I can make this dream come true, and maybe I'll shoot in another day when I become a nuclear scientist, or you guys just gonna die.
Okay, can I ask question? Oh. I do wish that you can be a scientist, but not to kill us. But that will be my question. Okay, we have such a really bad population problem.
Yes.
But why do you think that this can help to reduce human population? I mean, I get it that people is the problem, but is there another way to, like, without being a Thanos, right? Half of the world will be missing because he said that he wants to create a nuclear and to reduce half of human.
I agree.
Why? And can you find something else to do without harming people?
Right. So first of all, I've decided to use this option because birth control aren't that effective. I mean, birth control, birth pill. People don't usually use that, especially dumb people like Indian people.
Okay.
All right. So I've come to an option that's 50-50. I mean, the half of humans live and the half of humans are dead. So I've chosen that option to reduce the human population because there's no other option left. I mean, birth control, people aren't going to use that. So I decided just make a nuclear and put it on the overpopulation country like Indian and no, I love Chinese, okay?
But Chinese is the first. No, then I'm kidding.
I'll just put it on India or I think United States if I don't work for NORAD. Or maybe if I were smarter in the future, I'll think of another solutions.
Okay, please do take another solution and search for another solution rather than killing people, okay?
Right.
Because you are smart enough and you have everything that human needs to control us without killing us. Okay?
Right.
Okay, thank you very much.